Thank you very much, Prakash, and good afternoon. So I'm Dan Sun. I run the HarvestMark division of Trimble. Just a brief overview of Trimble. A lot of people probably don't know it. We're a Silicon Valley company, 40 years old, and we have a lot of verticals, industries that we cover, from agriculture to transportation logistics to construction, geological surveys and all that. And so from the very beginning, we've been a IoT company for 40 years, and we were very, very strong in the GPS space. That's kind of where the company started. About a few years ago, we acquired a startup called HarvestMark, and they're one of the leaders in traceability and quality management. So they have some really interesting patents, very original patents on traceability, encryption, and anti-counterfeiting. And so you can see we've got some really interesting customers there in that space. And it was mainly a software play. And what we did after that is we think we're an IoT company. We have a lot of vertical industry expertise in agriculture, transportation, logistics, and all that. How can we put all these things together? So we're actually on a path to integrate everything from the sensors to the software to algorithms and analytics. And we have a lot of expertise, as mentioned, in the agriculture space. We've got a lot of machine controls. You go to the field, a lot of the tractors actually run on our smart sensors and software, so they're autonomous, and they can run by themselves in the field at sub-inch level accuracy, and do the spraying and irrigation, all that stuff automatically on demand with smart prescriptions behind them. So the idea is that if we know what's going on in the field, we know the soil samples, we know the chemical composition, we know the moisture sensors, we know the temperature, we know the wind, we know the sunshine, we know all that, we know the seed, we know the chemicals applied. Then we have a lot of knowledge about what's going on in the field, what's growing in the field. And then we can trace that from harvesting all the way to the supply chain, retail, wholesale, to consumer home. And then we can link what the consumers are thinking about the products and all the parameters in between, like temperatures and humidity and all that, and see if there are any decays, any problems with the products. And then that will become a closed loop. The closed loop will actually tell you which variety, which growing method, which location, what kind of seasonality will have the best taste, the texture, or longer shelf life, and that will reduce food waste and improve consumer satisfaction. So that is really what we're trying to do. And so coming back to the sensor integration, so we do track a lot of sensors between what the software traceability part is doing at HarvestMark, but also our sister divisions within Trimble. So I mentioned in the field we track soil moisture, or there's weather, all kinds of weather-related data. There's location. Certainly, you need to know which field and which plant. There's temperature. There's a date, time, and all the way to harvesting, and then you want to know the Brix value of your fruits. You're harvesting. Is it sour? Is it sweet? There's the temperature of the fruits, because usually fresh produce you want to keep them at low temperature. For example, most berries you need to put them in the cooler within 2 hours and cool them down to about 32, 33 degrees. And for every hour it's exposed to room temperature, is going to lose a day of shelf life. And even that, you have only about 2 weeks of shelf life. So that's how fresh it is, how sensitive it is. And of course, there's quality data, right? This quality could be size, it could be defects, it could be any molds and all that information. So we record that. There's visual sensors. In the field we'll also use, Trimble has a sensor called the green seeker. Actually will take the photo and rate the nitrogen level in the leaves, so that we know if it has enough nutrition in it, right? Once you get the products in the supply chain, the transportation piece, we then track And of course, not only the temperature, but also the location, acceleration, humidity, all kinds of things. And of course, when you get the products delivered, someone at the distribution center of a retail store will have to do the physical inspection of the products to make sure they meet whether it's USDA standards or the retail standards, right? So they check again the temperature, they check the defects, they check the bricks value very often. There's date and time, so then they know the shelf life, they know the age of the products, and we know how long that load has been harvested and in the supply chain, and how many days they're going to stay in the warehouse before they get put on the shelf and bought by consumers. And the same thing, and all the way to the consumer home. We actually have consumers as human sensors. So consumers will give us feedback on how they like the product. Do they like the taste? Do they like the aroma? Do they like the appearance? That was very interesting. So one of the customers that we have, you see there's a pack of strawberries. As Driscoll's is, I'm sure a lot of you guys have had Driscoll's strawberries. They, with our help, we manage a consumer panel. They collect all kinds of data, but the consumer panel has about 600,000 people on that panel. That's a very big panel, and they get a lot of consumer data along with the supply chain data, the temperature data, and they were able to fine-tune the taste and the texture and the aroma of their berries so that they get a better consumer satisfaction. So as a matter of fact, they're the #1 berry brand in the US. They have probably 30-40% market share, and they also have the highest price premium. That's really rare in the produce industry. It's commodity, but the #1 market share has about 30% price premium because they have better products. And of course, we get all the data there. We analyze them. We send reports, and they make operation decisions based on these data and the reports. So the value is not about the IoT. The value is really about the data. So here's a view of how we actually monitor the loads being delivered from point to point. It's actually on the blockchain that we developed together with our transportation logistics division within Trimble. So, in this case, when a truck leaves a city, we monitor that along the way. So we know not only where the truck is, but also whether it's, what the speed is, what the heading is. We monitor the temperature in the back of the refrigerated trailer, and we monitor the trend of the temperature. The temperature is going up, and it's going to, hit 50 degrees, which is the preset threshold for the refrigerator load. Then a warning will get sent to the driver, so the driver can stop and check if there's anything wrong with the reefer unit, or if it's going too cold, it's below zero, it's going to freeze the load. The driver get an alert as well. But also we monitor the environment. We have sensors connected all to the ground in the highways, so we know the ambient temperature of the trucks and that's driving through, right? So for example, if you have to go through the Death Valley, the temperature outside could be 120 degrees, but your reefer unit is only certified for 110. So you're not going to go through that. The AC is working, but it's not going to be effective, right? So for those kind of situations, we will send alerts and either stop the driver, wait until the temperature is cooler, or reroute the driver. So all these dynamic things are going on. At the same time, we will have sensors on the truck monitoring not only the temperature information for the load, but also the trucks themselves. Whether they need maintenance, whether they have any mechanical issues, and whether the driver has any fatigue. We will have videos monitoring the driver and all that safety stuff. So this is really an integrated sensor and software algorithm play. Then we apply a lot of machine learning to it. And the result is a lot of rich information dashboards. So this one, it's trace activity. You can see a lot of dots on the map. That's where the products are being checked. And I think this one is really it could be age information, it could be quality information, right? So the greener it is, the younger the product is, which means they're fresher. And this one is more of consumer satisfaction feedback, so you can go by item and see if they're happy with the product or not. And then we have, retail operation. We have links to the retail stores, and we check their temperature on the shelf or the back room. And obviously that has a very, very strong influence on the product quality. And we provide the reports to not only the retailers, but also the berry growers or the produce growers, so that they can monitor what's going on in the retail space. So you can see in this chart on the top, I think that's Minneapolis. Minneapolis has actually the worst freshness score of all the markets we're monitoring, even worse than Boston or New York, which doesn't make sense because a lot of the produce are sent from California to the East Coast, and Minnesota is not that far, right? So that basically tells you that there's something going wrong within that area that the retailers we're tracking are not doing the good job. Maybe their backroom was not cooled down to the proper level, or someone forgot to close the door. After all, they're managed by minimum wage, high school kids in a lot of the retail stores. So these are really the sensors that will tell you the story, and we aggregate the data and tell both the brand owners, but also the operators, what are the operational issues they have, and so that they can go fix them. And again, we trace all that consumer satisfaction, all that quality data back to the region, to the farm, so that we can run analysis around which farm has better production, although they have the same variety, but maybe they have different growing methods, maybe they have a different local climate, all that factors. So that's really a feedback loop we're giving our customers all the way back to the farm, or even to their nursery when they develop new varieties to grow and market. And just more of these. And this is interesting. This is a ranking of all the retail chains in the country from a consumer satisfaction or freshness score. So we actually tell our customers, the produce growers, which retail chains are actually doing a better job in terms of maintaining better quality and all that. So that's kind of where where I'm going to end, and we're going to have a little conversation and talk about the IoT uses.
Thanks, Dan. So this is supposed to be, Dan, a fireside chat.
We don't have fire,
but at least this looks somewhat like a fire here. So that was very interesting. I don't think many in the audience would have realized when they walk into a Whole Food that Trimble has something to do with the stuff that they buy from there, right?
That's, we have a lot of things going on.
Very interesting, yes. So you really articulated how IoT plays in tracking and tracing fresh food. What else is, I know you talked a little bit about agriculture. What else is Trimble doing in the IoT space?
Oh, we're doing IoT in many places. Like, I mentioned the trucks. We've got all kinds of sensors in the trucks. We have a lot of sensors in the field, in the ag field. Right. I mentioned the green seeker. We also have a lot of things in the construction space, like it could be an angle sensor, it could be a weight sensor, it could be a hydraulic sensor. So an interesting thing, and another example is like we have a business that's running for the excavators. If you think about the excavators would dig up the dirt or stone, whatever, to have weighing capability in the bucket. That's a really, really hard engineering question because the angles could be different, the locations could be different, every load is different. Yes, so we got a lot of sensor, a lot of computing in there to actually weigh each bucket, how much earth they're removing, right? Yep. Why do we want to do that? Because you want to maximize the load of the trucks, right? You overload it, the truck's going to have a problem, a safety issue. They have to go somewhere to unload. You underload, you're wasting capacity, right? So you want to load it just right. And that same technology is being used in agriculture as well, because every truck has to be filled, and you want to fill just the right amount.
So IoT is beyond Nest and the Smart Fork.
Oh yeah, it's
There's a lot
everywhere.
more
I
to
think
it
we're
there.
we're probably one of the best kept secrets
In the
industry.
Valley. So
in the Valley, and
40 years, old
yeah.
company is the IoT leader here.
Yes.
Interesting. So we kind of talked about IoT. We talked about traceability. Is this just a hype, or there is a 40-year-old industrial company now being the IoT leader just because IoT is a hype, or what is driving Trimble to be in the IoT space?
I think it's really the data, right? Because if you look at today, data is really the key for a lot of the industries. Just think about the Googles and Facebook of the world, how much data they have on humans. We need to apply the same level of data or information to the machines and to really drive productivity change. And that's really common whether you're in construction or you're in agriculture. The data and the model and the algorithm, that's why we have AI, that's why we have IoTs.
Okay. So when you walk into a produce store, or when you walk into your next house that you buy, there's something Trimble has something to do with that.
Absolutely. We have a lot of things. And
so before I open up to the audience to ask questions, what's the one thing that you want as a takeaway for the audience from your presentation today?
Yeah, I think the takeaway is that IoTs are everywhere, and they're increasingly connected. So what Tony was talking about, that you need to have a system, a cloud of connected IoTs to make sense, and also a lot of algorithms. And Trimble is actually a very big player in that space.
Right. Thank you. So I will open up the mics for the audience to ask questions.
Right here.
Is it on?
Yeah.
Since you're able to trace everything almost related to from the seedlings to the food on the table, I was wondering if you can detect harmful parasites and bugs and bacteria like E. coli?
Oh, absolutely. So the trick there is the traceability itself doesn't tell you anything. It's really what data you attach to it. You need to have a sensor. Whether you take a sample and do the lab test, but there are also new technologies coming up that we have seen that can, give you a quick swab and within a minute or two tell you whether there are any, harmful pathogens in the product that you're doing. And the other thing is, a lot of the food safety is really a process safety, so you need to have a system to manage that. You want to have sensors not only in the field, but also in your processing plants and monitoring, water quality, the cleanness of your facilities and the machinery and the workers and all that. So it's more of a system. It's not just, you have traceability. It doesn't automatically give you food safety.
Oh, cool. Thank you so much for the presentation. Really, really fascinating. One question that I had was around the piece for blockchain. So it seems like you guys have control over the entire supply chain, so you have access to data at each section of it. So I'm curious why you need to use blockchain rather than just use a database to manage all the logistics.
Right. So when we started, we didn't use blockchain. And by the way, we don't have control of the entire value chain. And that's part of the reason is we bought a company that was more a cloud-based SaaS solution that's offering software that works, right? But with Trimble, because we have both the agriculture in-field operations, we also have solutions in the transportation logistic piece. Blockchain makes a lot of sense to connect those because there's separate things. You're talking about separate companies, different players. A single solution doesn't really work there. And from a data integration perspective and from flexibility perspective or security perspective.
I wonder if you could contrast your architecture to what we saw in the last presentation, what Tony told us about, particularly the IoT edge part. And there's sort of an underlying question that goes with that. Yeah, how much compute power do where's compute power going in these localized areas, in the tractor, in the whatever unit is out there? And how much local processing and decision making how do you see that going?
Right. So it really depends on what kind of things you're tracking. If you're just simply tracking the temperature of the truck, you don't need a lot of computing power, right? But if you try to compute something, on the fly in the field, deciding whether you need to irrigate the right amount or apply the right amount of chemicals, then you probably need to have something. A lot of that is actually handled not at the edge, but at the server level. We'll make that decision because ag is, irrigation. It's not you need to react within the split of a second situation. You detect the moisture, soil moisture. You detect the temperature outside, and then you make some decisions. Essentially, it's a prescription that you drive your valves and your irrigation system to do that. So I would say that most of the decisions we're making are not computing intensive. The places where computing could be a little bit more demanding could be within the truck. Like say you monitor the engine of the truck, and depending on the temperature, the rotation, the road condition, all that, you may want to make some quick decisions whether you want to adjust some of the things, you send an alarm out. But even that, it's the onboard computer on the in the cab will take care of most of that that thing. So it's more distributed in the trucking, or in the excavator example that I made, and that was more demanding. But still, it's not any you don't need a huge computing power to do all those things. Yeah. You go ahead.
Yeah, I am planning to start like an Amazon Go type of a retail system. What can I expect from Trimble?
Amazon Go? You mean the retail?
Right.
Yeah. So we are generating a lot of IP. We're generating a lot of data, and that algorithm will get applied to the growers, to the suppliers. So those will translate into better quality, supplier, and better freshness to the retailers, whether it's Amazon or Walmart or Kroger, whoever. I think that's really where we see. Obviously, Amazon has their own, distribution operation and all that, right?
Yeah, I was just talking about the retail workflow. People come in, take their stuff and go.
Yeah, take the stuff and go. Right. So there's certainly a lot of sensors in that. I don't think we are directly involved in the Amazon. They may buy our sensors off the shelf, but we're not necessarily working with them, per se in that sense. But we do have a lot of things in indoor positioning, in imagery. Lasers and all that kind of stuff that could be useful within the retail space. We are working with a lot of retailers on, retail optimization, inventory control, and within the space.
I think one more question, maybe.
Yeah, I can see that you get a lot of data all the way up to the retail part.
Yep.
But when you get into the consumer, you don't know how a particular box of strawberries was tasting.
We do.
And how do you do that?
Yeah, so that's really the HarvestMark secret. So we have what we call the item level traceability. If you go to a retail store, you flip over to a pack of Driscoll's strawberries, if you will. You see a QR code there, and that QR code is a unique serial number for that particular clamshell of strawberry. So I can scan that QR code. As a consumer, you scan it, you get asked to join the Driscoll's online consumer panel. And they will give you a discount or a coupon or whatever, and they ask you to rate your experience. So that's how they get the information. But that every single code has a link to the specific variety, to the farm, the ranch it's grown. We know when it was harvested, and I have a lot of information behind that. Of course, as a consumer, you don't see that, but I see that, and Driscoll see that. So that's kind of how we track it down all the way to the individual item level.
Okay, last question.
Sure, thank you. Yeah, I was curious how you solve the distribution problem in this sector, because a lot of these growers, agriculture companies are small, there are thousands of them. So how do you sell your software down to these people?
Right. So the distribution model, although a lot of growers are small, there are only so many brands. They're usually controlled by a bigger brand. So Driscoll's I mentioned, and they have probably 1,000 growers in contract with them. So we really talk to the brand owners, and that will use the solution, and the smaller growers will adapt to get on the same platform. That's how we go, and very often they're global. So we have growers in all continents in the world, and that we help track.
With that, Dan, thank you very much. So we started the track with Tony trying to make everybody rich, and now Dan has come and told us how to eat fresh and healthy, and so there's no point in having a lot of money but not being healthy. So thank you very much for educating the audience about the traceability and Trimble solution.
Sure. Well, thank you very much.
Thank you.